Ah, kids. All right, we're back. I am going to find the force on the red wire first. So if I do this, I know my equation is F equals B I L sine theta. All right, if you notice though, I wrote my B in purple. The reason I wrote my B in purple and the reason that you are going to use two colors is that this magnetic field right here comes from the purple wire. So by writing it in purple, I am going to remind myself, oh, I need to find the magnetic field from the purple wire. The I is this I and the L is that L. Okay, and then sine theta. So if we do this, okay, I need to first find B. Well, how do I find B? I'm going to use my equation for a long straight wire, which is that. Okay, and then I'm going to plug my numbers in, and I get 4 pi times 10 to the minus 7th times 5 over 2 pi times 0.4. Okay, because they are 40 centimeters apart. So again, the reason you're doing this, guys, is by making this in purple, it's going to remind myself I'm relating to the purple wire, so everything has to be in purple. So if I use my calculator, 4 pi times 10 to the minus 7th times 5 divided by... Hang on, 4 pi times 10 to the minus 7th times 5 divided by the quantity 2 pi times 0.4, and I get 2.5 times 10 to the minus 6 Teslas. So I get B equals 2.5 times 10 to the minus 6 Teslas. And it is pointing in. So then if I want to do my force for the red one is going to be F equals, let me use the right color, 2.5 times 10 to the minus 6 times my current, which is going to be 6 amps, times the length, which is going to be 3 meters, and then the sine, it's 90 degrees, so that's just going to be 1. I don't need to worry about that. So then if I do my math, 2.5 times 10 to the minus 6 times 8 times 6 times 3, I get 4. My force on the red one is 4.5 times 10 to the minus 5th newtons, and it is pointing to the right. All right. Now, if we do the same thing for the purple wire, we can find the force on the purple wire. So if we set it up the same way, yes, I know you're having fun, hang on. So I'm going to get F equals, okay, and then it's going to be a red B, because the magnetic field here is from the red wire, I L sine theta. And if you plug your numbers in, again, I want to do for B, I am going to get, so B equals 4 pi times 10 to the minus 7th times 6 over 2 pi times 0.4. Okay, because, again, the magnetic field here comes from the red wire. I know that because I drew red X's, and so therefore I have to use 6 amps because that goes with the red wire. This is, again, why you're using two colors. If you plug this in, you get 4 pi times 10 to the minus 7th times 6 divided by 2 pi times 0.4. You get 3 times 10 to the minus 6. 3 times 10 to the minus 6 Teslas going in. Okay. So then if you plug this all in, I'm going to get F equals Okay, my force equals B, which is red B, which is 3 times 10 to the minus 6, times my current, which since it's purple is 5, times my length, which is 3, and then I plug my numbers in, and I get times 15. Whoa, wait a second. Man, I got the same answer. Except it's pointing the other way. Gee whiz, why would this number and this number be exactly the same, only pointing the opposite way? Let me think about this for a minute. Oh yeah, for every action there's an equal and opposite reaction. Bam! It still works, folks. There you go. All right, what a great problem. First, you got to use the first right-hand rule, the second right-hand rule. You got your B field equation, your BIL equation. It doesn't get much better than that. All right, bye, kids.